HTTP is the protocol of the web. It is what enables web clients and web servers to communicate. It is the engine behind typing in a URL and getting back a web page. But how does HTTP make this happen? Hi, this is FK, and in this fundamentals video, we'll be delving into the world of HTTP messages. In a typical HTTP transaction between a web client and a web server, what is simply happening is communication. The client is making a request to the server, and the server is responding to the client's request. In order to communicate, a client needs to send a message to the server about a request. And once the server is done processing the request, it communicates back to the client also using a message. The client then takes this message from the server and either displays the response, use it to perform some action, or initiate another request. So, HTTP can simply be described as a message bus, sort of a courier service for the web, responsible for transferring messages from the client to a server and also from the server back to the client. Now, what do these messages look like, and what types do we have? How do they flow from one place to another, and what are the contents of these messages? Well, by the end of this video, you will have answers to all these questions, and even more. Let's start with the types of HTTP messages. An HTTP transaction between a client and a server is a two-way communication. So, only two types of messages exist. We have messages sent by a client to request a resource from the server. These are called request messages. And the second type of message is the one sent by the server to respond to the client's request. And these, you guessed it, are called response messages. These are the only two types of HTTP messages available: request messages and response messages. Now, how do these messages flow from one end to another? I am sure some of you watching this video may have heard of terms like inbound and outbound. Or some of you may have heard of the terms upstream and downstream, when those smart engineering folks are referring to the direction of flow of HTTP messages. So, while you're here, let's clear that up. First, let's define and differentiate between inbound and outbound messages. HTTP messages always travel inbound to the origin server. An origin server is the server that holds the resource that the client is targeting. Proxies, gateways, and tunnels are not origin servers. So, any message going into an origin server is what is referred to as an inbound message. When a server is done serving the request, it then sends a response message which travels outbound to the client. What this means is that the terms inbound and outbound are relative to the origin server. Inbound messages flow into the origin server, while outbound messages flow out of the origin server. Now let's take a look at the terms upstream and downstream. You see, these terms were coined in a way to view HTTP messages like a flowing river of data. Please note, all HTTP messages flow downstream. Whether the message is coming from the client or the server, it would always flow downstream. This is because rivers or streams flow downwards and not upwards. The sender of a message is said to be upstream of the receiver. You get it? The sender is up of the stream because the message flows downwards. And the receiver is said to be downstream of the message. In a request message, the message is flowing from the client to the server. So, the client is upstream while the server is downstream. In a response, however, the server is upstream and the client is downstream. Other web components like proxies and gateways can also be either upstream or downstream servers based on the direction of the current message being sent. I hope that clears all the confusion on these terms for you. If so, awesome. Now let's take a look at what makes up an HTTP message. What are these guys really sending to one another? To understand the question we just asked, we'll start by first looking at the syntax of a message. Displayed on the screen is the syntax of a request message, side by side with the syntax of a response message. If you take a few seconds to skim through these two structures, you'll realize that the only difference, at least in terms of structure, is the first line. This very first line is what is known as the start line. After the start line, we have the header section. And after the header section, we have a new empty line followed by the body of the message. The start line and the header section together make up what is called the head of the message. So, the HTTP message syntax is simply a head with a body. The body is optional though, but more on that later. To begin describing the message syntax, I'll be breaking down the start lines for these two message structures. We will then look at the headers and body sections and what it contains for a request and a response message. Let's start with the start line for a request message. For a request message, the start line, or request line as it is also called, tells the server what to do. It is made up of the HTTP method, the URL or path to the resource, and the HTTP version. The method describes what operation the server should perform. This can be GET, to request a resource from the server, POST, to send data to be used to create a new resource on the server, or Options, to request the general capabilities of a web server or its capabilities for a specific resource. While the HTTP specification defines a set of common methods like the ones I just mentioned, not all servers implement all the methods. So, you want to check the capabilities of a server before sending requests to it. An amazing thing about HTTP is that it is designed to be easily extensible. This way, servers also have the ability to implement their own methods in addition to this. These additional methods are called extension methods. If you want a deep dive into methods, I have a whole video on that covering HTTP methods. If it is not out while you're watching this video, it means you're one of the first people to watch this video. So congratulations. Just in a week or two, I'm sure the HTTP methods video will be out. So, subscribe to the channel if you haven't and turn on your notifications bell so that you don't miss a single video that we post. Hello guys, this is FK, and honestly I am tired of all the debates and arguments I'm seeing on Twitter and Reddit about which programming language is better or which framework is better. While many developers are still lacking in the understanding of how programming languages work, how databases work, how web servers work, and how even software systems work. Lack of understanding of these main fundamentals has been the reasons for things like imposter syndrome, not knowing whether you're programming the right way, or even struggling to try to be a senior developer. So, I have taken it upon myself to teach these core fundamental topics. These topics never change, and they form the bedrock of any proficient developer, DevOps, cloud, or blockchain engineer. So, if you want to get free materials and videos sent to you every week, use the link below to join our fundamentals community. I can't wait to share exciting software fundamental lectures with you as we all strive to become better software engineers. Now back to the topic. Next on the request message start line is the URL to the resource being targeted by the client. This can be a full URL or a relative path to the resource within the host server. This tells the server the request the client is interested in, and together with the method, it knows what action the client is requesting to be performed on the resource. Finally, on the request start line is the HTTP version. This is the dialect of HTTP that the client is speaking. The client needs to speak an HTTP version that the server supports in order to access all the features for that version on the server. The client and the server can also negotiate to determine the highest compatible version they can speak. Most HTTP clients are capable of speaking multiple HTTP versions. So, that's the breakdown for a request message start line. The three components we have discussed are separated by white space, and together they instruct the server about the request. Now let's take a look at the start line for a response message. The start line for a response message, or response line as it is also called, tells a client what happened to the request. It consists of the HTTP version, a status code, and response text or reason phrase, all separated by white space. This HTTP version is a version of HTTP spoken by the server in responding to the client. This is often the negotiated HTTP version from the transaction between these two entities. Next, we have the status code. While HTTP methods on the request line tell servers what to do, status codes on the response line tells clients what happened with the request. A status code is a 3-digit numeric code that is used to convey the status of the request. You see, when you make an HTTP request, several things might happen. It may be successful, it can fail, the resource may not be found, or you might have sent the wrong request. Whatever is the case, the server uses a status code to let you know. HTTP status codes are grouped into different classes to help classify the state of your request. The 100 to 199 range simply provide information about a request. The 200 to 299 range tells you that your request was successful. The 300 to 399 range is sent when the target resource has been moved to another location. The 400 to 499 range tells you that you have made a mistake with your request or that you're not allowed to access that resource. And lastly, the 500 to 599 range tells you that the server messed up. If you're interested in nerding out on HTTP status codes, I have a video coming out on that also. If you're lucky, I may have already uploaded it to the channel. But for now, let's get back to the topic. Finally, on the start line for the response message is the status text or reason phrase. This is a human-readable version of the numeric status code. It is provided by HTTP to briefly summarize what the status code represents. While this should not be used by programmers within code operations, they provide a quick context to the status code sent. And that completes our breakdown of the start lines for both a request and a response message. Now let's look at the headers section. Following the start line comes a list of 0, 1, or many HTTP headers. These header fields are simply key value pairs separated by a colon character and an optional white space before the value. Like the example shown on the screen, which sets the content length value to 24. So what's the purpose of headers? Headers can be thought of as a way to package extra information along with the message about the request or response. This information can be used to describe, provide context, share information like authentication keys, or even instruct the receiving entity on an action to perform. Like the location header that can be used to instruct navigation from one web page to another. Each header stays on its own line, followed by a carriage return line feed. A carriage return line feed is simply a set of characters that move the cursor to the beginning of a new line. This carriage return line feed ensures that each header occupies one line. After all the headers, you then have an empty line to indicate that the header section is complete. Anything that follows after this empty line is considered as part of the body of the message. There are a lot of supported standard headers in the HTTP specification, and the specification also classifies headers into different groups. First, we have the general headers. These headers can appear in both request and response messages. For example, the cache control and connection headers. Next category is the request headers, which provide information about the request message. These include the user agent header, which describes the client making the request, and the referral header, which indicates the URL of the page that linked to the current resource. The next category of headers are the response headers. These headers, as you may have guessed, provide information about the response. Examples of these headers include content type, which tells the MIME type of the content being returned, if any, and location, which indicates the URL of the resource that should be requested in response to the current request. Next, we have entity headers, which describe the body, size, and contents of the resource itself. Examples of these are the content length and last modified headers. Lastly, we have the extension headers. Remember how I mentioned earlier that HTTP was created to be extensible? Yeah, you can also create your own headers even though they are not defined in the HTTP specification. You have often seen headers like server and X powered by. It might surprise you to know that while these headers may be popularly used in practice, they are not actually defined in the HTTP specification. Shocking, right? Now that we have looked at the start line for both request and response messages, and we have also looked at the headers section, we have covered the two sections that make up the head of an HTTP message. Now let's take a look at the body of a message. The body of an HTTP message is an optional part of the message. It is used when either the client or the server needs to send data to one another. For a request message, it is used to transport data that can be used to create or update a new resource on the server. For a response message, it is often used to return data back to the client, like a web page that is to be displayed, or the results of an API request. Messages can carry data of all digital kinds in their bodies. This can be plain text, images, video, HTML documents, software applications, yes, you heard that right, credit card transactions, and so on. The content in the body can be broadly categorized into three types. First, we have single resource bodies that consist of a single file of known length, like an HTML page or an image. This body can be defined by the content type and content length headers. Next is single resource bodies that consist of a single file of unknown length and is encoded in chunks. This is indicated by the transfer encoding header set to chunked. This is typically used for a large amount of data that needs to be streamed. And finally, we have the multiple resource bodies. These bodies consist of a multi-part body with each body part containing different sections of information. These are rarely used in HTTP transactions. Oh my, that was quite a deep dive. And now I hope you can confidently say, I do understand HTTP messages. If you have any video ideas on explaining fundamental concepts that you would like me to make, feel free to drop the titles in the comment section. Till I see you in another video, go be the best you can be.